A Beginner's Guide to Understanding the Layers of Blockchain Technology Part 2. The network layer, commonly referred to as the peer-to-peer layer, is responsible for internode communication. Discovery, transactions and block propagation are all handled by the network layer. This peer-to-peer layer ensures that nodes can find one another and interact, disseminate and synchronize to keep the blockchain network in a legitimate state. The consensus layer is essential for blockchain platforms to exist. The consensus layer is the most necessary and critical layer in any blockchain, whether it is Ethereum, Hyperledger or another. The consensus layer is in charge of validating the blocks, ordering them and guaranteeing that everyone agrees. Smart contracts, chain code and decentralized applications, dApps, make up the application layer. The application layer comprises the programs that end users utilize to communicate with the blockchain network. Applications give instructions to the execution layer, which executes transactions and ensures the blockchain's deterministic nature. It's the technology that allows Bitcoin, Ethereum, and other blockchain networks to function. This is the foundation layer, and its security is based on its immutability. The Ethereum network, or Layer 1, is what people allude to when they say Ethereum. This layer is in charge of consensus processes, programming languages, block time, dispute resolution, and the rules and parameters that maintain a blockchain network's basic functionality. Bitcoin is an example of a Layer 1 blockchain. These scaling solutions boost the network's throughput when used together. However, with the growing number of blockchain users, Layer 1 appears to be falling short. The archaic and clumsy proof-of-work consensus process is still in use on the Layer 1 blockchain. Also, the workload on Layer 1 blockchain has increased as the number of users has grown. This consensus approach certifies new transaction data blocks based on the staking collateral of network participants, resulting in a more efficient procedure. Sharding is a scaling solution for the burden on the Layer 1 blockchain problem. As a result, the workload can be distributed over the network to use more nodes' computing capability. Because the network processes these shards in parallel, several transactions can be processed both sequentially and simultaneously. The overlapping networks that sit on top of the base layer are known as L2 solutions. Protocols make use of Layer 2 to increase scalability by removing some interactions from the base layer. As a result, smart contracts on the primary blockchain protocol only deal with deposits and withdrawals and ensure that off-chain transactions follow the regulations. Bitcoin's Lightning Network is an example of a Layer 2 blockchain. The blockchain is the first layer in a decentralized ecosystem. Layer 2 is a third-party integration used in conjunction with Layer 1 to enhance the number of nodes and, as a result, system throughput. Many Layer 2 blockchain technologies are being implemented at present. Layer 2 scaling solutions. Layer 2 protocols have exploded in popularity in recent years, and they're proving to be the most effective approach to solving scaling issues in POW networks, in particular. Various Layer 2 scaling solutions are explained in the sections below. A nested Layer 2 blockchain runs on top of another. As a result, the manager's workload is reduced while scalability is improved. The OMG Plasma project, for example, works as a Level 2 blockchain for Ethereum's Level 1 protocol, allowing for cheaper and faster transactions. A state channel improves total transaction capacity and speed by facilitating two-way communication between a blockchain and off-chain transactional channels via various approaches. State channels examples include Bitcoin Lightning and Ethereum's Raiden network. In the trilemma trade-off, state channels give up some decentralization in exchange for increased scalability. Sidechains have their consensus method, which can be adjusted for speed and scalability, and a utility token is frequently utilized as a part of the data transfer mechanism between side and main chains. Rollups are Layer 2 blockchain scaling solutions that perform transactions outside of the Layer 1 network and then upload the data from the transactions to the Layer 2 blockchain. Layer 1 can keep rollups secure because the data is on the base layer. Users benefit from rollups since they help to boost transaction throughput, open participation and lower gas costs. The application layer is often referred to as Layer 3 or L3. L3 applications are what give blockchains their real-world applicability, as explained in the layered structure of the blockchain architecture. Because both blockchain levels have their own set of restrictions, the eventual solution will be to develop a system that can solve the scalability trilemma. Layer 1 is critical since it serves as the foundation for decentralized systems. The underlying blockchain scalability issues are addressed via Layer 2 protocols. Layer 3 applications are essential because they help to develop real-world use cases for blockchains,